Hi.
I have a couple questions, based more on what we already turned in and or the chapter four.
Okay.
And for the first thing, yesterday for the graphs that were due, I
Hold
was
on
having
1 second. Give me 1 second. I just because the people on the stream can't hear, so I just want to address them for a second, and then I'm
oh, I'm sorry, I didn't realize you had other people on.
no, that's fine. So, and you're for the Math 1 class, right?
I'm for the stats class.
Oh, okay. So I'm actually teaching class right now. If you have
You
questions,
are, oh, I thought it was office hours. I'm
that's
sorry.
okay. No, office hours just ended actually at 10. So, but I can help you.
Oh, okay.
Do you want to hop back in at 11? I can.
That would be fun.
Okay, I'll leave Zoom open at 11,
Oh,
and
thank
then
you.
okay,
Okay, sorry about that.
no problem, no problem. Okay, welcome everybody. So we're starting the Math 1 introductory algebra class. Sorry, I just had another student coming into Zoom. They were thinking it was office hours, but I'm going to help her in an hour when this class ends. So I did not receive any questions. So the assumption then is that everyone's ready to get 100% on the test, right? So I've seen about half of you, well, little less than half of you have done the practice test. For those of you who did that, good job. You did what you basically you did what you were supposed to do. You went in, you got into the practice test. You've worked on some of that material. You're starting to remember what you do and don't remember and don't know. And so then you can bring those questions and ask me. Good. It looks like there's a question popping up here. We'll take a look at that in a moment, and we can definitely talk about that kind of stuff. We'll look at those. And for those of you who didn't, I understand stuff happens, right? Parents, kids, jobs, all sorts of stuff. It's a crazy world right now. So if you weren't able to get to the practice test, that's not the end of the world. But it would have been ideal if you had. But that's okay. You still have until Sunday to do the practice test. But remember, the point of the practice test is to get you ready for the test. Okay, so that you can take the test and do well on it. So do the practice test first, right? Like I've mentioned before, I have students who do it the other way around. They take the test and go, okay, I got that out of the way. Now I'm going to go clean up the other homework and stuff like that. But if you'd done the homework and practice test first, then you'd end up doing better on the exam, on the test, okay? The test, it should be live. So I opened it up before class. They did change some settings in Delta Math. There's been some changes since the last time that I posted a test. So their interface was differently. So I hope that I did everything correctly. If for some reason you don't see the exam in there, so there's the exam 1 practice, and now there should also just be exam 1, so you can tell the difference between the two. They have slightly different settings. You don't have to do on the exam, you don't have to do 2 of the same problem, right? You just do 1, and then go from there, and then you'll have to get that done. So yeah, so if you have questions or you remember, oh yeah, I did have a problem that I was having trouble with on there, by all means, now's the time to bring it up in the next 45 minutes where I can help you with it. So it looks like, let's see, William, let's see, there's a question here. Will you get the grade from the exam right away? I believe so. Like I say, they changed it. This is one of the things that's irritating when they update software. Like if those of you who remember, they updated Zoom a couple weeks ago, and it took me a while to find which setting had been moved. So Delta Math's pretty good about that, but they changed some settings. There used to be an actual exam template, but now I had to go in and some of the options were missing, so I had to set it up. I think you can see it right away. I don't think it'll show you the solutions. Maybe it will, but I think it'll show you your grade that you got on it, and it didn't give me a time limit before, so I think you can kind of you'll have a bunch of time to work on it. So I don't know where they moved or what happened with the setting, but I wasn't able to find it. So I think, yeah, it will. I think you should be able to get your grade right away. Okay, good question. So it looks like, let's see, is this the It's got a weird view here. Okay. Substitution level 3 and solving systems of equations from context. Great. Let's look at those. Fantastic. Glad to see some questions so we can move forward with those. Let's do it. Let me erase this stuff from the other class. Okay, so where are we? It's substitution level 3. Okay, let's remember what kind of problem that is. Okay, so here we go. Let me make sure I'm looking at the right thing. Yeah, this is the practice. Okay, so substitution level 3. So here's the problem that we're looking at. 3x plus y equals negative 16. Y equals negative x minus 4. Now we want to solve this using substitution. Now, the reality is there's a problem on the test that says solve this one with substitution and solve this other one with elimination. Technically, I'm not going to know which method you use to solve it. It's really only going to be able to tell if you got the answer correct or not, right? So technically, you could use it either way, but I'm pretty sure that the way it tells you to solve it is the best way to do it. Like looking at this one, substitution is the best way to do this problem, right? So we'll go from there. So 3x plus y equals negative 16. So 3x plus y equals negative 16. And then, oops. And y equals negative x minus 4. Y equals negative x minus 4. Okay, so we want to solve this using substitution. That means we're going to substitute one into the other. And it's already set up for, it's already basically set up for substitution because we have one of the variables already solved for, right? So, okay, so that's good. We're seeing some more problems getting put there. Feel free, whoever needs, throw some stuff in the chat there, and I will try to go through those problems for you so you can see them done. So, good job, William. Keep throwing them in there if you need. Other people, throw those problems up in chat if you want to see some stuff done. Okay, so remember the way to kind of recognize when you should use substitution is if you have one of the variables that looks like it would be easy to solve for. Namely, if it has a coefficient of 1 or negative 1 on it. In this case, look, they've done the work for us. It's already solved for y equals. So what I'm going to do is substitute into this first equation. So where it says y, I'm going to replace it with what y is equal to, which is negative x minus 4. So when I do that, it becomes this. 3x plus, and now I'm just going to put in parentheses here, negative x minus 4 equals negative 16. Now in this particular case, it didn't really make a difference if I remembered to put the parentheses in there or not, right? The problem's going to come out the same either way, but most of the time it will make a difference. So putting those parentheses in there, I see it all the time, especially on like tests. Putting those parentheses in there is oftentimes the difference between the student remembering to do the distributive property versus forgetting to do the distributive property. If you forget to do the distributive property, you're going to get it wrong. Now, in this particular example, there's no distributive property to do, so that's okay. The problem essentially just becomes what it would be without those parentheses. But usually, those parentheses do make a difference. We just got one where it happened to work out that they don't. So the problem really just becomes this. Okay. And now, here's what we want to recognize. Great news. We have one equation and one variable. That's what we want, right? We started off with 2 equations and 2 variables. That's hard. One equation and one variable, much easier. Okay, so now we just set out. I forget if this was one of the first things we learned in the class. Maybe this was chapter 2 or something like that. Solving one equation and one variable, oh, that's much more straightforward. So let's do that. So 3x minus x is going to give me 2x. And then minus 4 equals negative 16. Then we're going to add 4 to both sides. So it looks like that's going to give me 2x equals negative 12. meaning that x must be equal to -6. If at any point you don't understand what I'm doing, make sure you ask. Get my attention, I can help you out. Okay, now we're only half done. Remember, the solution to a system of equations, we have to come up with a value for both x and y. All we have right now is the value for x, and for all I know, I made a mistake, right? It could be that all of you are looking at this going, "What? That's wrong. He just made a mistake there and doesn't even see it." But I'll catch it in the end when I check my work, right? That's what you want to be doing. Try to catch that work. If there's a mistake there, you want to catch it. Okay, so now it's easy. All I have to do is go back and plug this into one of the original equations. And so let's use the one that says y equals -x minus 4. So if I plug my value into that, I'm going to get the y equals, so it's going to be -6, right? Minus 4. Because the value that I'm plugging in is -6, and I'm plugging it into a -x. So there's this negative that's in front of the x. That's this one right here. And then there's this negative from the -6. That's the one that's right here. Okay, so altogether, -6, remember from pre-algebra, -6 is +6. 6 minus 4. So y equals 2. 1 second. So y equals 2. Okay? So that would mean our solution, the way we want, is that -6, 2 is the solution. So let's see if that makes sense. Let me plug it in here. If I plug in -6, I get -18 plus 2 equals -16. Yep, that's right. Now let's plug it into this one. So this would be 2 is equal to 6 minus 4. Yeah, so that should be right. So let's plug it in. -6, 2 in here. -6, 2. Making sure you're getting them in the right order. You might have solved for y first in some of these problems. Make sure you remember that's the second value, right? Y is the second one. So submit it. Way to go. Good job. There, I got it. Okay? So that's how you do that one. All right, let's see. Solving systems of equations from context. Okay, let's take a look at that one. So solving systems of equations from context. Is it solve or write? Solving. Okay, that's the one he's asking about. Okay, so there was a question here. So this takes more critical thinking. This is a harder problem than we just did. Before you were given the equations, here you have to come up with the equations, right? And this is, I know, like we hear it all the time as math professors, oh, I just hate the word problems. But that's what math really, for most people, that's what math really is word problems. Because unless you're a mathematician or scientist, you never just find an equation and have to solve it, right? It's going to be your job wants you to figure something out. And you're basically taking a word problem and figuring out what to do with it. So let's make sense here. What are we going to do? We have to do a bunch of things. We have to decide what our variables are going to be. We're going to have to decide which ones we want to choose, what they're going to represent. We have to come up with equations. So there's lots of steps here. But if you can do this problem, you basically understand that whole chapter. Maybe not exactly. 80% of that chapter on systems of equations. If you can do this, you're good with it. Okay. At a particular restaurant, each pizza roll has 60 calories. And each mini hot dog has 70 calories. Okay, so we got two types of food. They each have a calorie count. Okay, got it. A combination meal with pizza rolls and mini hot dogs has a total of 21 pizza rolls and mini hot dogs together and contains 1,380 calories. So I'm going to stop right there and ask myself, what did they tell me? They told me a count. They told me how many of the total items there were. Okay, I can probably make an equation out of that. And then they told me a total calorie count. Okay, I can probably make an equation out of that. So I think I know where to get the two equations from that we're going to use in this problem. Okay, good. Now I'll move ahead. Determine the number of pizza rolls in the combination meal and the number of mini hot dogs in the combination meal. Okay. So using anything besides systems of equations would make this problem very difficult. You could brute force it it would probably take you most of the day, right? It would take you a few hours probably before you came across the right number. If you just did guess and check brute force system of equation, we should have it done in a few minutes. Okay. So let's see. What do we want to call these things? Why don't we call them H and P? Why don't we use H and P for our variables? Because then I'm going to remember that's hot dogs and pizzas. I'm not going to mix them up. I'm not going to think that P is hot dogs and that H is pizzas, right? So that's what I'm going to choose. So let's define those variables. So let's go in here and say P is the number of pizzas hitting the wrong button. And H is the number of hot dogs. And we want to be specific. I see a lot of students that say P is pizzas and H is hot dogs. Well, what do you mean P is pizzas? What about the pizzas? Like P can't be a pizza. Your variable isn't itself actually a pizza. It's a representation of part of a pizza. So, like a characteristic of the pizza. So you have to say, well, P is the number of pizzas, H is the number of hot dogs. And then sometimes students say, well, yeah, that's obvious, right? It's not. Trust me, it's not. There are other problems where, they might be asking you about like the temperature of a pizza and the temperature of a hot dog, or the, different stuff about it. So saying that, and even in this one, there's calories in the pizza, calories in the hot dog. You want to say what it is that your variable is representing, because trust me, people get confused. By the end of the problem, they're confused about what the variable represented. So if you just write it down, makes it all a lot easier. Okay, so let's see. Let's go back and gather that information. So see how when I read that problem, I didn't just read it beginning to end. I think that's a mistake a lot of students make. They think it's like a history book. Just read it beginning to end and go, okay, I got it. There's too much information there. So even though I read it and I stopped after each sentence to understand what I was reading, I'm still going back to check the information. All right, what do we have? Well, there's a total of 21 pizza rolls and mini hot dogs altogether. So that tells us the total is 21. 21, right? Yeah, 21. So what does that mean? That means that one of my equations is that P plus H equals 21. That's the easy one to come up with, like pretty basic equation. It's just a total. We're just totaling them. P plus H equals 21. Okay. All right, got it. All right, now we got to make the one that's a little bit more complicated. Not bad, but a little bit more complicated. So let's see. We've got 1,380 calories total. Let's see. Yeah, okay. 1,380 calories total. 60 calories in a pizza roll. 70 calories in a mini hot dog. Interesting. Okay, so 60 calories in a pizza, 70 calories for a mini hot dog. So if I take 60p, 60p should represent the number of calories from the pizzas, right? Because P is the number of pizzas. If you multiply that times 60 calories each, that gives you the total calories from the pizzas. All right, by the same reasoning, was it 70? 70 calories for a mini hot dog. So 70H should represent the calories that come from the hot dogs. If the hot dog is more calories, why on earth would you not just choose the pizza? The pizza is going to taste better anyways. I guess people like hot dogs, I guess. 60p plus 70H, so that equals a total of 1,380 calories. Oops. Equals, not subtraction. There we go. So right there is our system of equations. Right? We just solved it. So see how we had to come up with that, but we had to take our time to get there. We had to define some variables. We had to come up with equations. We had to do some different stuff, right? So now we can start to solve it, right? We can solve this any way we like. I think it doesn't really matter which way we use. Probably about the same amount of work either way. Why don't we use substitution? So P equals 21 minus H. So all I did was solve the first equation for P. And now we're going to use that to substitute into the second equation. If you want to solve this one with the elimination method, go right ahead. Totally fine to do that. Completely acceptable. So let's go 60. Now instead of P, remember I'm putting those parentheses there. Instead of P, I'm going to use 21 minus H. Also, if you see me make a mistake, let me know. So I don't spend 10 minutes doing the problem wrong. Sometimes when you're explaining at the same time, it's easy to make a mistake. So 60. So see, my P became 21 minus H, and then we will just have plus 70H equals 1,380. Okay. And that's good. We now have one equation, one variable. That's the good news. We're going to be able to solve for H pretty readily here. So let's see. What do we got? Let's see. 60 times could be 120. So 60 times 20 is what? 1,200? Yeah, 1,200. So one more would be 1,260. So it should be 1,260, right? Yeah, that should be right. And then minus 60H plus 70H equals 1,380. Okay. So what have we got here? So negative 60H plus 70H is going to be 10H. And then if I subtract 1260 from both sides, I'm going to get what? I'm going to get, let's see, 1380 minus 1260 is going to be 120 equals 120. So that should be what? H equals 12. So that's 12 hot dogs. Mini hot dogs, whatever they're called. At this point, always a good idea to just do like a common sense check and just ask yourself, does this even make sense? Let's see. Does this seem reasonable in our problem that we would have 12 mini hot dogs in a combination of 21, a combination meal with 21 pieces? Yeah, that seems reasonable, right? You can catch a lot of mistakes by just looking at it and asking yourself if that's reasonable. If I got a negative number, that wouldn't make sense, right, in this context. What if I had gotten H equals 50? How could you have 50 mini hot dogs in a platter with only 21 pieces in it? It doesn't make any sense. But 12 does make sense, so good. It's not guaranteeing that I haven't made any mistakes, but so far there's no red flags that I'm like, that I've made some kind of like terrible mistake, right? Okay, now the easy part, we're just going to go back, plug it in. Look, we can do this one in our head. If H is 12, then what's P? Well, P would be 9, right? We can just get it by plugging 12 in right here. P plus 12 equals 21 means that P would equal 9. I say it's easy, and then watch, I'll probably mess it up, but let's see. P equals 9. If anyone's not sure, I'm certainly happy to go back and explain things further if we need to. Okay, so 12 hot dogs, 9 pizzas, and we can check it. Okay, that works. And if I was actually taking the test right now, I would double check that it works in the second equation too. It's totally worth getting the problem right to just take a few extra, 1 extra minute to plug in 12 for H, 9 for P, and just double check that it works here and that I get the right numbers, right? But for the sake of explaining, I'm going to skip that step. So let's see, 12 and 9. So 9 pizzas, 12 hot dogs. Let's see, 9 pizzas and 12 mini hot dogs. All right, I got it. Okay. So look, they did basically the same thing as us. P, number of pizzas, H, number of mini hot dogs. Came up with the same equations we did, and then you just solve it like we've been doing. They got P equals 9 first, so they did it. They did it substitution, but they solved for H. So see, it doesn't really matter. It worked fine when I solved for P. They solve for h first. It all comes out the same. It's all fine in the end. Okay? All right, then what do we have? Context inequality systems graphically level 1. Yep, let's take a look at that. Great. And if anyone wants to throw up another problem, it looks like we'll probably have time for at least one more problem after that. So if anyone has something they want to see, throw it up there and we can be ready for it. Context inequality systems graphically level 1. Context inequality. Okay, here we go. All right, let's take a look. Okay. Savannah owns, oops, I don't really want to make it smaller. It'll be harder to read, so I'm going to have to keep scrolling up and down to make sense of this. Savannah owns a food truck that sells tacos and burritos. She only has enough supplies to make 150 tacos or burritos. Okay. I wonder what the limiting factor is. Tortillas, maybe? Okay. She sells each taco for $3.50 and each burrito for $5.50. All right. Savannah must sell a minimum of $660 worth of tacos and burritos each day. If X represents the number of tacos sold and Y represents the number of burritos sold, write and solve a system of inequalities graphically and determine one possible solution. Okay. Now, you might ask, why are they using X and Y now? And in the other problems, they were being smarter about the variables that they chose. Like here, if you weren't graphing this, you would probably want to use T and B. T for tacos, B for burritos, right? You're not going to mix that up. You're not going to think that B is tacos and T is burritos. So why are they doing that here? It's mainly because you're used to having an X-axis and a Y-axis. Actually, let's see. Oh, I'm going to have to, I always forget. I have to go the other way. I have to make it smaller, and then it gives me a thing. Okay. So basically, because you have your X-axis and your Y-axis, and students are used to this being an X and Y. If you wanted, it could be tacos and burritos. You could make that your axis, but that's a thing that's kind of another level up. It sometimes confuses students to have a T-axis and a B-axis. So that's why they're sticking to X and Y. So don't sweat that part. So let's see. What do we have here? So we have inequality. Savannah must sell. Oh, she only has enough supplies to make 150 tacos. Okay, so that means that, let's see, X is tacos, Y is burritos. I got to remember that straight. Keep that straight. Okay, so let's go down here. So we have one inequality that says X plus Y must be less than or equal to 150, right? The number of tacos plus the number of burritos has to be less than or equal to 150. I think that's what it said, right? She only has enough supplies to make 150 tacos or burritos. Okay, so that's one of our inequalities. But notice they're not letting us put that in here. This is in the form of y greater than, or we can change that inequality, but they kind of want it. It looks like they kind of want it like in slope-intercept form a little bit, right? Or at least where it's solved for y. So then let's do that. So we're going to go y is less than or equal to 150 minus x. Now we have it in the form that I can enter it into the problem. So y less than or equal to 150 minus x. Okay, let's try it. Y. So I'm going to choose the less than or equal to 150 minus x. And we can plot that. And then, but it's making us choose which side to shade. Okay, so how do I know which side to shade? Well, let's pick a test point. How about 10, 10? Right? Oftentimes we choose 0, 0, but then students get in the habit of thinking that's the only thing you can choose. Let's choose 10, 10. If I put 10, 10 into here, is 10 plus 10 less than or equal to 150? Yeah, right? So 10, 10, which is right here where the cursor is pointing, that is a solution, meaning we want to shade this side. We don't want this side. We want this side right here. So there. That's what that should look like. Okay, great. Now let's move on to the second one. This one's a little trickier. Savannah must sell a minimum of $660 worth of tacos and burritos each day. And let's see, a taco's $3.50. Well, what kind of taco that is? And a burrito for $5.50. So we've got let's see, 3.5, or if you know, here's what I'll say. 3.5 x plus 5.5 y must be what? Greater than or equal to? I'll double check. I'm going to reread it again and make sure I'm thinking about it correctly. Greater than or equal to, was it 650 or 660 or something? Let's see. I think it was 660 maybe. Yep, 660. Okay. Savannah must sell a minimum of $660 worth of tacos and burritos each day. Okay, so I was right. I just sort of doubted myself here. And let's make that 660. Now, I go, wait, why is he using 3.5? 3.5 is the same as 3.50. 5.5 is the same as 5.50. So if you feel more comfortable putting the zeros on there, go ahead. But it's kind of like the last problem we did. 3.50x, that's the amount of money generated by tacos. 5.5y, that's the amount of money generated by burritos. Because if you take the number of burritos you sold times the price of the burrito, that's how much money is generated from burritos. So that has to be more than or equal to 660. Okay, but that is not in a form where we can, that's not in a form where we can graph it yet, because it wants us in the form where we've solved for y. So let's take this, and I was showing you this, but I'm going to get rid of those zeros since they don't serve much point here, and they're actually going to make the problem a little bit more work. So let's multiply everything by 10, because I want to get rid of those decimals. So I'm multiplying the entire equation by 10 so that all the decimals will go away. How do I know I'm multiplying by 10? Because I want to move the decimals one place. If we had a decimal that had to move 2 places, we'd have to multiply by 100. That is, you multiply by 10 and then 10 again. You multiply by 10 for every time you want to move the decimal. We could leave the decimals in there. It's just going to make it a little harder to deal with. So let's see. That's going to be 35x plus 55y is greater than or equal to 6600. The number's getting bigger. Right? Add that 0 on the end. Okay, now we got that. All right, let's see. Gonna get a little messy when we have to divide up here. That's okay. So let's do this. Let's see. Looks like we could divide everything by 5. So let's do that. Let's divide everything by 5. So we're gonna get 7x plus 11y is greater than or equal to, let's see, how many 5s would there be there? I'm afraid I'm going to mess it up if I try to do that in my head. Let's see. Um, 6,600 divided by 5 equals 1,320. 1,320. And we still don't, it's still going to be a little messy to solve for. So let's get that 11y by itself. And like I say, if I make a mistake, point it out. Don't be afraid. 11y is greater than or equal to 1320 minus 7x. And then we're going to divide everything by 11, and I don't think that's going to come out nicely for either. Oh, 120, so the first one comes out nicely. So we'll now get 11y is greater than or equal to 120. So 1,320 divided by 11 is 120. But this one's going to be messy, right? So this is going to be minus 7/11ths. Oops, that's not how you do fractions in here. I'm thinking of the other one. Hold on. So I got to do fraction 7/11ths x. So if I haven't made any mistakes, this is what it should look like. I'm not convinced I haven't made a mistake, but just because once you, like, when the numbers come out real clean, it was usually designed that way. But once we have these problems with fractions, you know, I'm sure you know what it feels like. You're a little less confident. You're like, maybe I made a mistake in there. I'm not sure. Oops, this shouldn't be 11 anymore because I divided by 11, right? So it should be just y. we go. Okay, so y greater than or equal to, all right, we've got y greater than or equal to 120 minus 7/11 x. 120 minus 7/11 x. Plot that. And then now we have to figure out which side we're shading on. I think we're going to shade on the outer portion, but let's just double check. Let's put 10, 10 in there again. If I put 10 in here, is 10 greater than or equal to 120 minus 7/11 times 10? That would be 70/11. So no, that's not. So by using the test point, just pick a test point, right? Any point you want. I'm picking 10, 10. That is not a solution, so I was right. We want this area over here. So that's the one we're looking for. So we want the doubly shaded area. We want the part that has been shaded both times. So it's this region right here is what we're looking for, if I did this correctly. Let's see. So now you just pick a value. You just pick a grid point in here. She can't sell half a taco and half a burrito, right? There are some times when you can sell a partial unit of something, but I guess she could technically sell half a taco and half a burrito, but that wasn't given to us as part of the description. So I think a reasonable person can make the assumption she's selling whole tacos and whole burritos, right? So you try to find a grid point. Let me see if I can zoom this in so we can see a little bit better. Let's see. Here's a grid point. So what would that be? That would be 40 tacos and 100 burritos. So 40 tacos and 100 burritos should work. So Savannah could sell 40 tacos and 100 burritos. Let's see if I mess this up. Nope, got it. So but notice there's more than one answer. Any of these grid marks in here would work, right? Any of these yellow dots right here, those are all options that would have worked, right? And then technically these should work too, but they don't have the yellow dots on them. She could sell 104. She could sell 0 tacos and 140 burritos, right? She'd actually be making more money that way. But anyways, we got it. Was that the one I did? 20 and 110? No, I did 40 and something, right? 40 and this was the point I did. 40 and 100. So either way. Now, these options don't all make her the same amount of money, right? Because burritos are worth more. So she sells fewer tacos and more burritos, probably makes her more money, but she can't, apparently her business, she can't just sell all burritos. She's got to sell tacos too. For revenue, at least. We don't know what her profits are on the tacos and the burritos. Okay, so that's how you do that. So, good. I'm glad, William, I'm glad you asked some questions. That's great. That sort of guides me which problems to do, because if I just guess some randomly, those are probably not the ones I would have picked. So I'm glad that I was able to do some problems that students specifically wanted to see. That's great. So, are there any other questions regarding material on the test itself, anything like that? Do make sure you get it done. I'm giving you days to get an exam done, so that there won't be any kind of extensions or anything. So don't wait till the last minute and then have a power outage or something. No questions? Okay, then with 9 minutes left, we'll end a little bit early. Feel free to hop into Zoom and ask me questions. I want everyone to do well. It would be awesome if no one had to do the retake. If everyone came in and did well on the exam and passed it, and they didn't have to sort of do extra duty next week studying for a retake and stuff like that. That'd be awesome. So hopefully you all do well, prepare properly, and good luck to all of you. Shouldn't really need luck when it comes to a test. Just know the material is really what you need to do, and you'll be fine. Okay, then I'm going to shut down the YouTube stream. Anyone who wants to hop into Zoom and talk to me one-on-one, do it. Okay? All right, enjoy your weekend. Be safe. Don't overheat. Stuff like